Find the domain of the vector valued function. So we have three components here: t squared, tangent t, natural log of t. So we find the domain for each function, and the domain of this function will be the most restrictive one. Okay, first component t squared, and for t squared there is no problem, and it's defined for all reals. For tangent t, if we look at the graph, so we have vertical asymptotes at negative pi over 2, pi over 2. Okay, then we have 3 pi over 2. In fact, 1 pi over 2, 3 pi over 2, 5 pi over 2. Those are odd multiples, odd numbered multiples of pi over 2. Same thing, negative 1 pi over 2, negative 3 pi over 2. So all reals except odd multiples, plus or minus. So how do we write odd numbers like 1, 3, 5, etc.? That's just 2k plus 1. Okay, where k is 0, 1, 2, 3, 4, etc. Or in this case we can also include negative 1, negative 2, etc. So all reals but odd number multiples of pi over 2. And last component is natural log of t, and it's defined for only positive numbers. Okay, natural log of 0 is undefined. So the domain for this is 0 not inclusive all the way to infinity. So this is so our domain will be anything bigger than 0. At the same time, due to tangent, we need to exclude these points: pi over 2, 3 pi over 2, 5 pi over 2, etc. So let me write that. Domain of this vector valued function, due to the third component, we can only go from 0. Okay, so 0 through all the way infinity, minus, so we have to subtract these points. Okay, set minus is like slanted minus sign. 2k plus 1 pi over 2. Okay, these are the points we need to exclude, where k is a, so we have to exclude pi over 2. So k is just 0, 1, 2, 3, etc. When we put 0, we get pi over 2. When k equals 1, we get 3 pi over 2, etc. Okay, final. Or we can write t must be positive on the right side, and t cannot be equal to 2k plus 1 pi over 2. Okay, where k is an integer. Okay, final.